Uh, Welcome to all to this podcast about climate. It was called The Climate Crisis. How can research institutions respond to it? So the speakers today work at the laboratory APC, Astroparticle and Cosmology. This is a mixed research unit located in Paris between the CNRS, the University PICO, and other research institutions in France. The lab carries on research on astroparticle physics, on cosmology, on multi-messenger astronomy. And one of the major activities indeed is to work on new cosmic messengers. So this could be gravitational waves, neutrinos, cosmic rays. So the lab includes about 200 staff between researchers, engineers, and administration. And the speakers today are all members of the CNRS, so the National Center for Scientific Research in France. I will let them introduce themselves. We can start from Matteo Barsuglia. Welcome.
Good morning. Thank you for this invitation. I'm Matteo Barsuglia. I'm a research director at the CNRS. I'm working since 30 years in the field of gravitational waves. I served as national scientific responsible for the European Virgo project, gravitational wave detector based in near Pisa in Italy. And I actually am the leader of a team about gravitational waves at APC. I'm also involved in activities about science and society. I was the director of the Center Cosmos Sciences and Societies of the Laboratory APC. I'm still involved in several activities about outreach and relationships between science and scientific community, practice, and ecological crisis. I'm coordinating the environment group of a French network about gravitational waves, and I also lead ethics workshop for PhD students and for researchers about the relationship between science and society.
Thank you, Matteo. So next, I would like Sonia Hedri to introduce herself.
Hi, so thank you, Giulia, for the invitation. So, yes, my name is Sonia Hedri. As Giulia said, I'm a CNRS researcher at this APC Laboratory. And my field of interest is the search for what we call astrophysical neutrinos. So I'm using these neutrinos, which are particles which interact very little with us, to understand the inside, or the mechanisms underlying the working of cosmic objects. And in particular, I'm working on an experiment called KM3Net, which is a very large-scale infrastructure located deep inside the Mediterranean Sea. And I'm part of a relatively large team of researchers at APC who are contributing to these experiments. I'm in particular interested in how stars are ending their lives in a process called supernova.
Thank you, Sonia. So our third speaker is Lindsey Clark. So Miles, please.
Hi, Giulia. Hi, everyone. Thanks for the invitation. So I'm a research engineer at CNRS, also at the Astroparticle and Cosmology Laboratory in Paris, like Sonia and Matteo, where I'm also the head of the instrumentation department. So I've been working mainly on the high energy physics, astrophysics, actually, space projects. That's how I started my career. And recently, in the past 6 years, I've moved to managing large-scale international scientific collaboration. So I was first as a technical project manager of the KM3Net neutrino telescope that Sonia just mentioned for the past 6 years. And today I'm still working at the interface between science and large-scale project management, such as Virgo, like Matteo mentioned, and also the Einstein telescope recently. And alongside my research activities, I'm very interested in the connection between science and society, especially questions related to sustainability and how research can evolve in the context of ecological transition.
Thank you, Miles. So indeed, as we said, today we are here to talk about how research institutions and researchers at large face the climate crisis. So, Sonia, I would start with you, but first of all, what do we mean by climate crisis?
Yes, so what we call the climate crisis, it's in fact part of a more general like environmental crisis. And what we mean by this, we mean that human activities are causing irreversible changes, like an irreversible deterioration of our environment, which is going to have a huge, potentially devastating impact on our ways of life. There is also a decrease of biodiversity, and we are consuming more resources than what Earth can regenerate each year. So now about the climate crisis. Climate crisis is only a part of this wider crisis, and it manifests itself in a rise in the average world temperature caused by the accumulation of greenhouse gases, in particular CO2, but also things like methane, for example, in the atmosphere. We can see this because, for example, the amount of CO2, like the concentration of CO2 in the atmosphere is now more than 50% higher than the one measured during the pre-industrial levels. It might seem like not much, but in fact, this concentration had been stable for around 6,000 years. And there are very interesting articles by the NOAA organization, for example, the National Oceanic and Atmospheric Administration, which you can check out for this. And so this accumulation is caused by human activities, notably the burning of fossil fuels, but also deforestation and other factors. You can see this in the report of the IPCC. The average temperature, it has already increased by 1.3 degrees compared to pre-industrial levels. And by 2100, it's going to increase by 2.7 degrees if we do not correct course, if we remain with the current policies, according to the Climate Action Tracker. And this has a huge impact on the environment and on our living conditions, with major and potentially devastating transformations. The CO2 concentration now is as high as around 4 million years ago, and the world was widely different then. In particular, sea levels were more than several meters higher than they are now, which could have, again, a cataclysmic impact on coastal regions. And so now we are meteorological services are foreseeing more heat waves with temperatures reaching more than 50 degrees in France. The glaciers are going to melt, which is going to contribute to the rising of the sea levels, so more floods. And more floods could be caused also by heavy rainfalls because if the atmosphere has more greenhouse gases in it, it can also hold more humidity. And these consequences, we're actually already seeing them today. We're having more heat waves on average during the last decades compared to the last 50, 60 years. You can check this out again. There are interesting articles on the website of the Oxfam. This can lead to droughts, to, of course, some deaths due to excessive heat. We have heard about all the deadly floods in Europe during the last years and all the forest fires also. And they are there are huge consequences, of course, in the whole world with, for example, massive droughts in Somalia in between 2020 and 2022, and huge forest fires in Turkey. These are only examples. So to summarize, it's part of a larger crisis. It's caused by human activities, and we are seeing the consequences now, and they are going to get worse if we don't change our way of, for example, producing or consuming.
Thank you, Sonia. So I will go to Miles. We all work in France, so to face this situation that Sonia is explaining, are there already official guidelines or recommendations concerning the ecological impact of research activities?
The simple answer is yes, but there's a more complex answer to that because there's many layers. The first layer, of course, comes from science, obviously, comes from the facts and the data. This comes from the IPCC, so the Intergovernmental Panel on Climate Change, as most of us know. And they write reports, and in the so-called AR6 report, they clearly state a trajectory that we should follow if we want to keep the global warming below 1.5 degrees. And basically, they say that we have to reach a decrease of minus 43% of emissions by 2030 compared to 2019. So this roughly translates into minus 5% of green gas emissions every year for a very long time. And so an important point is that they tell us what we have to do, what we want to reach, but they don't tell us how to do it. So this is a matter of policies and politics, obviously. But as a matter of fact, it applies to all countries and most importantly to all sectors. So research is therefore expected to contribute to that in one way or the other. So then this trickles down to geography. So we live in Europe, we live in France, you might have heard of COP meetings. These are conferences of parties. One of the most famous ones, obviously, is the COP of Paris. I think it was in 2015, where we collectively made the pledge to try to limit global warming to plus 1.5 degrees. And the COPs are the places where nations make their pledges. So there's no real constraint. Every country can come with a different pledge, and no one will tell if it's good or bad. I mean, we can check if it's coherent with climate justice and with the trajectory that the IPCC tells us to do. But there's nothing really binding. But that's where the pledges are made, and they're meant to be incremental. So more and more, important years after COP after COPs. So it all boils down to the EU pledge that we call the national determined contribution of the EU, and France is under the umbrella of this pledge. And the objective is minus 55 degrees of green gas emission by 2030 compared to 2090. And to reach net zero by 2050. So net zero basically means, simply speaking, that the amount of green gas emission we produce is directly compensated by the carbon sinks, like forest or oceans. So then all the countries implement their own national strategies that follow this umbrella from the EU. In France, it's called the SNBC, and there's a lot of acronyms. It means Stratégie Nationale Bas Carbone, so it's the national strategy to follow that. And basically, it follows exactly the same reduction, so minus 5% emission per year. So these are national obligations. They're not optional initiative. And interestingly, these NDC pledges are now written in law. So you might have noticed that recently there have been cases of lawsuits against governments. We had an instance in the Netherlands, the Arganda case, and the Affaire du siècle in France, where private people, let's say, can now sue the governments if we don't follow these objectives and are now written in law. So it makes it, it creates a completely different dimension to transition now. So yeah, this is the nation. In research, in public research, we are under the umbrella of the Ministry of Higher Education and Research in France, which also translate these objectives. So noticeably, they wrote a climate and biodiversity transition plan. And this is obviously not only focused on CO2 and green gas emission, it's a system-wide transition plan. based on three main axes. So we don't have time to go much into details, but the three axes are education, to try to integrate ecological transition into all curricula from students. Research, so the topics of research are trying to make this transition happen, and also institutional operations, obviously. So how do we reduce our own footprint? So buildings, digital infrastructure, mobility, etc., etc. So this comes with a set of concrete rules also. Okay, I won't go into details, but a few very, very tangible examples. We're not allowed, for example, to take a plane when there's a train alternative, but it's below 4 hours. We're not allowed to travel, for our work by car beyond 300 kilometers. And there has been, a circular note, let's say internal, that asks us to reduce our mobility by 20% by 2024 compared to 2019. So I'm not sure if this has been respected, but nevertheless, it was an intention from the ministry. So now environmental responsibilities are becoming part of how research units are designed, managed, and evaluated. So as it was mentioned during our presentation, we work in public research. We work more specifically, at university, but also some of us for CNRS, which is the main, let's say, research body, institutional body in France. And this problem of transition has been assessed, has been tackled, say, not completely, but there has been some initiative recently. I'm thinking more specifically of the COMET, which is the ethical committee of CNRS, who wrote a very interesting report in 2022, and it tried to address this question of sustainability in research activities. And yeah, in a nutshell, they say that environmental impact is also an ethical issue now into research. It should be taken as such. And research should integrate ecological responsibility in its practices. And one of the very interesting part of the report I find is that they really encourage that this topic is discussed at every level, at every layer that constitute research, public research. So, from a research group at the coffee machine all the way up to the headquarters of, the institutions, because that's the only way to make it happen, is that everyone, trying to tackle this question. We'll come back to that. So this really moves the discussion from an optional good practice to something that is entering the dimension of research ethics nowadays. And finally, at CNRS, we also have some policies that are coming through. For instance, quite recently, CNRS wrote very interesting. I encourage people to go and read it. Schéma directeur, which is a strategic plan that concerns and try to address all sustainability questions regarding our research activities, so biodiversity, governance, and mobility. So there's many topics addressed in this schéma directeur, in this strategic plan. Concerning CO2 emission more specifically, they show that most of our CO2 footprint at CNRS concerns infrastructures and purchases, which is not a surprise. I mean, we work in very large-scale experiments for some of us. I'm thinking of the LHC, for example, or astroparticle physics infrastructure, which are very demanding in terms of resources and therefore in terms of footprint. But if you look at the CO2 footprint at a laboratory level, take out these big and large international infrastructure, really look at the way we work activities, it's often our mobility that counts a lot, at least in our research field, in astrophysics and cosmology. We have to travel to conferences, we have to go and build big infrastructure to, many places around the world. And that's at lab level, that's one of the main part of the CO2 footprint we see. Anyway, the CNRS also in this plan came up with some targets. So regarding mobility, for example, they asked us to reduce our spending on professional travel and the number of flights we do by 30% between 2019 and 2027. So 2027 is next year, so times go by fast. But as I said, it's not only about CO2. There's many, many encouragements and measures regarding, for example, responsibility in procurement, like promote greener public procurement strategies and criteria, digital sobriety, energy efficiency for our building, obviously, reduction of laboratory waste, sustainable food and catering also, and also many measures regarding governance and institutional changes. Most interestingly, every research unit now at CNRS needs to appoint a transition officer who's responsible to locally tackle these questions and try to translate these national incentives in a more local environment. So yeah, that's it. An important nuance, as you can see, is that many objectives are national and institutional. But as I said, CNRS is quite large, more than 30,000 people working there, and that's just the CNRS. There's other research bodies in France, and we all have different constraints. In biology or archaeology, you won't have the same constraints as we do, for example, in astrophysics and cosmology. So the point is that each lab needs to experience these constraints differently, and try to find different ways to implement. So the interesting thing is it's a top-bottom process because, as I showed, we have all these national objectives. But nevertheless, it's also a very important bottom-up process because then each lab with their own constraints need to think how these objectives can be put in. Yeah, I think that's it.
Thank you. So, Matteo, so Miles explained very clearly the, the framework, at least in France, but it applies to Europe, I would say, in different nuances. And so now let's dig a bit more into this. So, what are the responses to this framework and these regulations that come from the research community facing climate crisis?
Yeah, so as Miles pointed out, there are two kind of responses. There are institutional responses, top-down, I would say top-down initiatives. For instance, Miles quoted the opinions of the ethical committee of the CNRS, which are very important, especially this opinion of December 2022. So integrating environmental issues in the research practices and ethical responsibility. Other opinions, more recent, about the responsibility in carrying out researches which have risks, but also potential benefits. So it's really a place, the comets, great research for the scientific community and to feed these discussions about environmental crisis. Miles also quoted the publication of the CNRS strategic roadmap for ecological and societal transition, which contains guidelines, ideas to change our practices, day-by-day practices. And in parallel with the institutional top-down initiatives, there are bottom-up initiatives. For instance, the creation of the network Labos 1.5. It's a network of researchers, more than 1,000 members from the French academic world, of all the disciplines of the fields, with the goal of better understanding and reducing the environmental impact of scientific research activities. So the Labo 1.5 offers tools, reflection forums to assess and help laboratories to reduce the carbon footprint, for instance. Other bottom-up initiatives are several articles, op-ed in newspapers, for instance in Le Monde, but also in other newspapers, where a group of scientists express their opinions about environmental crisis. And let me say that coming back to the ethical committee of the CNRS, the ethical committee recommends that the responsibility of researchers facing the environmental crisis is not only about a reduction of the impact in the daily activities, but also about the long term. The comment says, I quote, considering the environmental impact of research solely in terms of the carbon footprint of research in the making is too simplistic for two reasons. On one hand, research is unlike other professional activities in that its purpose is to produce knowledge, which is likely to produce new representations of the world, to inform a particular model of society, to guide the choices of public and private actors, and to provide the basis for technological or conceptual innovations. In this recommendation, we are encouraged to think to the long term, not only to the practices, but also to the research subjects. And so following the opinion of the comments, there are a group of scientists analyzing the role of the research in these times of environmental crisis, the responsibility in general of science in the society. So, of course, there is a very fundamental questions that we should try to answer, which is the best compromise. If there is a compromise to have, and which is the best compromise between reducing the environmental footprint of research and our scientific objectives and ambitions. And this is at the level of a scientific community, at the level of a country, as the France, or at the level of a broader community of the Europe or the planet.
This is very interesting. I think the part about the reflection on research culture and research practices. So how does this translate locally for you, for instance, in the lab, at the university, on the field, let's say?
Yeah, so first of all, let me say that this, of course, is a crisis, the environmental crisis, but also this crisis offers an opportunity to rethink, to review our practices, to step back and reflect on our impact on society. And I think we have to take this opportunity very seriously. At the level of our lab, but this is the case of hundreds of laboratories in France. We have first, as we are scientists, and we started by a quantitative evaluation of our impact, our carbon footprint. I mean, ecological crisis is not about only about carbon footprint. It's clear, but it's a first metric of our impact. And to do this, we have used tools developed by this network, Labo 1.5. This network did a great work to assess our impact. So assessment of impact of purchases, travels, food, buildings, computers. And this estimation allowed us to understand better which are the practices that are important to change, to review, to reduce the impact, and as Miles said, to have an alignment of these general objectives, reduction of objectives set by Europe and by the country. So now, for instance, in our lab, we are in the process of discussing these good practices, changes of practices. For instance, how to take more the train with respect to the flights, move to more vegetarian food, recycle materials, change computers less often, optimize the computing itself. And its process, of course, is very long. Changing practices is very difficult, but it's important. And there is a collective dimension of this work, discussions, the level of the lab, which are very important, and I think they are very rich. And this collective dimension is very important because it's a way to be more aware of the crisis and to share opinions and information. We have at the lab other initiatives. For instance, we run a journal club around the coffee and sometimes some cookies about environmental issues. For instance, we have discussed the ethics, the opinions of the comments of the ethical committee of the CNRS, or for instance, a recent paper about the estimation of the carbon footprint of research infrastructures in astronomy. And of course, we are in a university, and the university offers several occasions to discuss with colleagues. We have workshops. The university offers also the way to train ourselves, to share information about good practices and also information how to teach the environmental crisis to students and to integrate all these aspects in our research activities.
Thank you, Matteo. Sonia, I'm coming back to you. So Matteo mentioned, I think it's very interesting, this collective dimension. In science, especially in our community, astroparticle physics, usually, often, we work in large collaborations because instruments are big and they require a global effort. So I think there is a balance there between the local effort and the community at large. So can you maybe tell us a bit more, as part of a large international collaboration, what happens in your research community?
Yes, so that's a very interesting question indeed, because one big difference between what Miles and Matteo have explained about what happens in France and in our lab and what happens in these large international collaborations is that in this latter case, there is no unique organism, unique authority giving guidelines or making some rules. So what happens in particle physics, astrophysics collaborations is highly variable because it will often depend on the sensitivities of the different labs involved, laboratories involved, and especially on the sensitivities of the people who are occupy senior positions in these collaborations. So I cannot give you a common answer. Because, in the scientific community, these sensitivities, these positions can be very different. I think basically everyone agrees that there is a climate crisis, that it is caused by human activities and that something should be done about it. But the question people disagree on is the question of whether us scientists as a community can and should make a big fundamentally change our way of doing research, given that, well, we represent only a small impact, a small percentage of the carbon emission. This is always a question of the individual effort versus the collective effort. So it is there in general in society, it is there also in the scientific community. So I can give you, well, a few examples of things of efforts which are being made in different collaborations. So some of them have working groups who study the carbon footprint of the experiment and of the research activities associated with the experiment, and who study the different sources of the carbon footprint. And for example, for an experimental project here, the Future Circular Collider project has made such a detailed study, which you can find on the CERN website of the European Organization for Nuclear Research. And in general, I would think that in most experiments, there are discussions about how to reduce the footprint associated with travel, which has been already mentioned by Miles and Matteo. Because since we are international collaborations and often projects are being carried out, like research is being performed through smaller collaborations involving different laboratories, people need to meet. And generally, we try to meet 3 or 4 times per year in a given place, generally near one of the member institutions. And we're trying to be more mindful about the place we choose for these meetings, which can be also a bit difficult because sometimes organizing a meeting in a given laboratory helps improving the visibility of this laboratory. So we shouldn't leave out some laboratories which are a bit far away from the center. Sometimes some places can be in expensive locations like Paris, for example. So we have to take all these factors into account, but accessibility by train is becoming more and more important. And in some experiments, people are also experimenting with creating like hubs for the meeting. So if you have a large concentration of laboratories, if, for example, one large concentration of laboratories in Europe and another large concentration of laboratories on another continent, then you could have like 2 meeting places on these 2 continents where people could gather instead of requiring everyone to meet at one given place. So as you can see, these are just examples, and this is still work in progress. So we still need to think about our way of doing science, especially in international collaborations.
I think that the positive message here is that the research community at large, so not just specialists of climate or meteorology, are involved. The community is starting a kind of larger shared reflection about how we do science at large. And I think this is the most positive message, I think, from what you all explained today. I think we're reaching the end of this, so I would like to thank you all again, Sonia, Miles, Matteo, and thank you all for listening to this podcast. Bye.